All right. Hello, everyone. Welcome back to Online Data Programming 1. This is lecture 41. It's May 1st. This is our final video lecture of the semester. It's been a great semester for me. I hope you guys have enjoyed it. I hope you feel like you got your money's worth. Today we have a really fun topic scheduled, randomness. But we're going to start off with just a couple of announcements. All right, well, maybe a lot of announcements. First up, P10 is due today. That's Friday, May 1st. And please remember, late days may not be used on P10. In fact, everything must be turned in by May 1st today. The reason for that is we need to have time to grade everything, to deal with any problems that might arise, regrades if necessary, and it is incredibly difficult to change grades once they've been submitted to the registrar's office. So we need to make sure we get it right, which is why we need everything turned in today. All right, along the same lines with grades, please remember that we've redistributed the points from the semester because we were all told to go home, watch Netflix, and teach class from our basements or our bedrooms or living rooms or wherever. So the redistribution of points is posted on Piazza. It's pinned there. And the grade will get, we're still sticking to the same guidelines from the syllabus, just the percentages, how they were allocated, the assignments is a little different. But you can find that on the syllabus. It's 95 guarantees you an A, 85 guarantees you a B. We reserve the right to bring that down, but we will not make it harsher than that. And Mina and I will be talking about that sometime in the next week and deciding exactly how we're going to curve the class. And this time of year, I get a number of emails, it seems, where people want me to compute exactly how well do I need to do on the final project to guarantee a B. My recommendation is that you guys go use some Python, write a little bit of code, and compute that for yourself. All right, let's see, next announcement. Final project was assigned on Monday, and it is due 10 days after that. So that'll be Wednesday, May 6th at 11:59 p.m. Good luck, you guys. Please remember that's a do-it-yourself, no partners allowed. Treat it like an exam. All of the questions are based on something we've seen in a previous project. In fact, it's labeled which project that we were inspired by when we wrote them. They do use different data sets, so as you go through this, definitely go back, refer to your old work, and if you take anything from your old project, please remember to just let us know where you got it from. I just mentioned grading, submitting grades to the registrar. It's really hard to change things once we've submitted them, so we want to get it right. There is a form on our webpage, or I believe Mina actually, a pin to Piazza for grading, resubmission, deadline extension. You can go there, you can fill out that Google form. It puts them all in one place and makes sure that you're on our list, and we will take care of that. All right, next up, course evaluations. Oh yeah. So it's incredibly important that you guys fill out the course evaluation. I was just taking a look at this. Right here, this is where we're at. 32% response rate for Data Programming 1, for my section at least. I can't see Mina's. And today, 5/1 is the last day. So 32% is pretty bad. Please, go fill that out. I know you're sitting on the couch watching Netflix. Your little brother's playing music there. Just take a minute. It doesn't take very long. This is incredibly important for me this semester because I applied for a full-time job with the university beginning in the fall. They're going to look at these. If you think I did a good job, I would love for you to tell me that, and they're going to use that to evaluate me. If you think I did not do a good job, or if you think there's some things that I could work on, I would love to hear that too. So go fill out the evaluation. Actually, pause the video. Go do it right now. All right, now next up, contact Mina if you're interested in being a mentor next fall. We're looking for people who, maybe got a B or better. These are the people that work at the shelf, answer questions. They work during the lab time, help people work through these projects. If you're interested in that, send Mina an email. I believe she already emailed everyone in the class. You can just follow up there. If you enjoyed this course and are looking for more, please remember that UW-Madison has added a new data science major. Please consider taking the second course in that sequence, CS 320, if you're interested in that direction. If you decided that you really enjoyed the program aspect of this and you're thinking maybe I want to do computer science, the beginning sequence there would be 200, 300, 400, which all focus on Java. If you felt that the programming part went really smoothly, you might consider jumping into 300 right away. If you really liked it but felt like I would like the full experience, maybe a little more practice, maybe 200 is the right place, check with your advisor as you make a decision for what you plan to do with your future. And finally, last announcement, office hours will be changing for the week of finals. Our TAs have their own final exams. We'll likely seeing reduced office hours from TAs, but more office hours from Mina and myself. The Piazza post has all of those listed, so go ahead and check those out. All right, so let's get started talking about randomness with a little example here. So one of these sequences of coins was generated randomly using Python, and the other one was handpicked. I didn't actually handpick it myself, someone else did, so I got to actually go through and try and figure out which one was generated by hand and which one was generated randomly myself. And I'll talk you guys through my thought process. But first, let's head over to our webpage. This is today, Friday. There's a worksheet right here where I've got this same example in there, and we'll talk about it. We'll actually do some simulation. There it is, simulation right there. So go ahead, go to the pause the video, go to the web page, grab the worksheet, and then jump back to follow along with the worksheet. All right, so here it is. Up at the top, I've got all of my imports that I'll need for today. Save you guys some time. We'll be using pandas. We'll be using NumPy. The new random stuff here, we'll be looking at the choice function. And we'll be using some pandas to do some analysis. We'll be making some plots. And then, let me run this real quick. We will also be using some cool Jupyter Notebook style worksheet stuff. Okay, so here's my example. I've got two sequences of coins. One of these was handpicked to try and trick us, and the other one was generated randomly using Python's choice function. So we just need to decide which one is the one that was randomly generated and which one was handpicked. So pause the video, stare at these for a minute, and make a decision. And then write your guess in this cell right here. All right, do that now. All right, welcome back, guys. I guess number 2 was the one that was randomly generated. So I had a couple things I was thinking about when I was looking at these coins. First up, if you look at this, the top sequence has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 heads out of 16 coins. Now, the expectation value, we'd expect that exactly half of them would be heads if it were flipped enough times. So the expectation value is be 8. So this is exceeding that. The other thing I noticed that really jumped out at me was we've got, as we go along, right here, starting here, 1, 2, 3, 4, 5, 6, 7 heads in a row. Flipping 7 heads in a row, it seems kind of unlikely. So my guess was that this was the one that was handpicked. Turns out it wasn't. This was the one that was randomly generated in Python, and this is the one that was handpicked. It almost, I don't know if you might want to think about it as looking too perfect. It's actually got 1, 2, 3, 4, 5, 6, 7, 8 heads. Not more than 2 in a row at any point. It's exactly hitting that expectation value. But this is the one that was handpicked. Number 1 was the one that was randomly generated. So I got this wrong. I guess number 2 was random, and it was not. So we're going to be looking at a couple things. How likely is it to get 7 heads in a row if we flip 16 coins? And how likely is it that we'll get 11 out of 16 that are heads? So those are the last 2 things in the lecture. We got to talk about how to actually use Python to get some random numbers first. So I'm going to head back over to PowerPoint and introduce those new functions, and then we'll start going through the rest of the worksheet. All right, be right back after I flip back to PowerPoint. I'd like to start off by recommending a couple of books for your summer reading. First up on the list is Thinking Fast and Slow. This book is a mashup of statistics and psychology and addresses how people misinterpret chance and sequences of random events and draw the wrong conclusion based on human nature and their interpretation of things, in particular statistics. Next up, The Signal and the Noise by Nate Silver. Nate Silver, statistics genius. Had a boring job in insurance and decided to do only things that actually interested him. He made a ton of money playing online poker, where he took advantage of his knowledge of statistics. He did some analysis of baseball players to identify underrated players, also with a lot of monetary value in it. And then moved on to predicting elections and is the founder of the famous website 538. It's named that because there are 538 people in the Electoral College. And This particular book, The Signal and the Noise, is about what kinds of things people are good at predicting and what kinds of things people are not good at predicting. All right, next up on my list, we did talk about plotting during this course, and as long as I'm recommending books for the summer, I got to recommend The Visual Display of Quantitative Information. This is a great book about how to make your plots more effective and better communicate what point you're trying to get across. Finally on my list, Statistics Done Wrong came highly recommended. I haven't read this one myself. Apparently it's a really deep dive into statistics and deals with a lot of the same issues these other, we'll be discussing today with bias and significance and chance. So why do we care about randomness? I got 3 reasons here on this particular slide. First one, games. We've all been told to go home. We're getting a lot of extra family time, and a lot of us are using that time to play board games, and almost all those board games have dice. If we were trying to play games that didn't have randomness, if you think about a computer game, we could play them once and then figure out what the pattern is that the computer is using, and then we could play it again and always beat the game. Second one on the list, security. Almost all computer security involves some sort of secret, like a password, something that's hard to guess. It turns out that humans are very bad at picking passwords that are not hard to guess. And it's so much better to go with a randomly chosen secret or randomly chosen password. And finally, the major focus for this course, data programming in general, and what we're doing today is going to be simulation. We're going to be simulating, flipping those coins lots of times to try and decide whether things are likely or not. And we're going to do this with the goal of trying to predict the likely outcomes of possible scenarios. And it'll allow us to explore lots of different options. To do that, we'll be looking at the Python's choice module. So Python comes with a built-in random module. It's limited, but pretty good for quick and easy tests. The NumPy module also has a random module, which contains a powerful collection of functions. I recommend you guys check out the documentation for the NumPy random module and see all the different things it can do. Today we're only going to be looking at one thing, just the choice. That's probably all we'll have time for. There are a number of slides in this slide deck which will be available for download, which also go into plotting histograms, which are a great way to visualize these random results. But I'm going to leave that to you guys to flip through the slides on your own and try some of those examples out. All right, I'm back in Jupyter Notebook. So first up, random selection from a list using choice. Let me grab a new cell here. It's really simple to do this. I'm just going to call the command choice. When I click in the cell correctly, choice. This is going to take a list of things. So I'll have option 1, option 2, however many options I want. So in this case, just to demo this, I'm going to leave this here as a comment so you guys have notes of how to use this. And then for my example, I need a list. So I'm going to use the square brackets, and we'll select from one of 3 objects. How about a rock, piece of paper, or a scissors? All right, and then if I run this, it's going to choose one of these from the list. If I run the cell again, it chose paper a second time. This time it chose scissors, running again and again and again. It's just going to continue to choose one of these from the cell. By the way, that's Control-Enter to run the same cell without moving down to the next one. Shift-Enter will run the cell and move it down like that. Okay, now, so pretty straightforward using choice. We also have some options that we can use in this choice block that make it a lot of other things possible. So let me go grab another cell. I'm going to copy and paste this line and talk about some of these other features. So the first parameter is a list of things to choose from. And then the next parameter, keyword parameter, is size. And I can say size 5. And this is going to let me choose 5 different things, and it's going to return them as a NumPy array. Let me demo that real quick. I'm going to get a new cell for that. So I'm going to take this command, and we'll just print out the type of it. And just doing some experimenting. Now we can use this NumPy array just like we can a list. In fact, one of the things you can do with a list is make a series out of it. So I can say series, and then I can put my command to generate a NumPy array from the choice right there in the series. When I run this, I now get a series. So the index, this is the boring list version one where I'm just using the index as the same as the positional integer. And then my values here are just randomly selected. If I run this cell a bunch of times using Control Enter, it's going to give me a different random list of or series of objects from that list. All right, let me just move this cell down. It's actually supposed to be under the random series block there. Some other things I can do with this NumPy array. So let me grab this sequence again. Choice, there we go. That should give me an array, a NumPy array. I'm going to stick this in a variable. I'll call it A for array. I can access that. Let me just run this again, print it out. There we go. Grab another cell. So I can access the elements of this array just like I can any other list. It's almost everything is identical to a list. So if I want to grab the second item, that'll be at index 1, that should be the rock. There it is, the rock. If I want to grab the paper, that's at 0, 1, 2. Paper. Okay, so using square brackets, I can access elements from the NumPy array just like a list. All right, next up, multi-dimensional random series. Let me grab a new cell. So I'm going to take this right here. This size parameter right here also accepts a tuple. So right now I'm just giving it an integer, just a 5. But I can also give it a tuple. Remember, we defined tuples using parentheses, and in this case it's going to have 2 numbers. The first one will represent the row, and the second one will represent how many columns we have. So rows and columns. I'm going to put this in a comment because I don't have rows and columns defined. But then we'll go ahead and we'll do this with, let's say we make 5 rows and 2 columns. And this is going to return a multi-dimensional NumPy array. If we stick this into a variable, I'm going to call it array, A for array. Run this, we'll print that out. Actually, just print it like this. And I can grab another cell. We can access this the same way we can with a list of lists. In fact, if you look at it carefully, we've got square brackets and then items of square brackets. So essentially it's exactly like a list of lists. And so if I want to grab a particular item, I'm going to grab, let's see, how about this rock right here? That's in row 0, 1, 2, element 0, 1. So that should be the rock. That's that rock right there. And then just a reminder, I'm going to put some more comments in here. That when I have this row and column, sizes, rows and columns, let me just copy this so that I can add a little comment. So I can add a little comment right underneath it. This rows is going to be, think about it as the going down direction, and columns are going to be how many things go across. All right, so I've got some little arrows. That's not the letter V, that's a down arrow, and this is an arrow to the right. So when I put the 5 in here, I get 5 rows, 1, 2, 3, 4, 5, 2 items in the list going across. We can also use this choice function of the NumPy array that results from a choice function to create a pandas data frame. So I'm going to grab one more cell. Please remember that when we create a data frame, this can take a list of lists, which is essentially what we're generating. Let's see, where was that? Oh, I stuck it into a series. Right up here, we were generating a list of lists. Nope, right here. This is what I'm looking at. List of lists. And we can do the same thing. Because this is essentially a list of lists, we can stick that in a data frame and create a pandas data frame. So let me grab the command, the choice function there. We'll stick that directly in my data frame creation and run this. And now we've got a gorgeous looking pandas table that we can do more analysis with. We'll use data frames more in a few moments when we start doing some more in-depth simulation style analysis. One of the things that I want to talk about next, though, is exploring bias. Is this a fair function? Take a look at this data frame we just created. We're just choosing 5 rows with 2 selections each. Is it fair? It looks like we've got 1, 2, 3, 4, 5 instances of paper, but if we count the number of scissors, there's only 2 scissors, 3 rocks. So the question we want to address next is this fair? And maybe a better way to look at the data would be to actually plot it. So I'm going to go ahead and do that now. I'm going to grab a new cell. I'm going to copy this command that created the data frame. Start with that. I'm going to stick this in a series so we can make a bar graph from it. And I don't want a multi-dimensional. Let's just do 15 of these. That, if it were actually fair, we would reasonably expect that we'd pick rock 5 times, paper 5 times, scissors 5 times. All right, let me make sure I didn't screw up. So there we go. So we've got a number of, this one looks like it's got a lot of rocks in it. 1, 2, 3, 4, 5, 6, 7, 8. I was expecting 5. All right, well, anyway, so once I have a series, to actually take this and do all the counting for us automatically, the command is value counts. So I'm going to actually stash this in a variable, s, and then I'm going to say that value counts, vc, is equal to s dot value counts. And just remember what this looks like. We'll go ahead and print out vc. This is going to create a new pandas series, but now the index is going to be the items from my list, and the value is going to be the number of times they appeared in the list. Now, when I ran the cell again, it completely read this. In fact, if I just keep running the cell over and over, it's going to give us a new pandas series every time, and then recompute the value counts. So what I'd like to do next, actually, is create a bar plot from this. So the value counts plot and bar, and now we can actually look at this pictorially and see that it looks like we're getting 7 of the rock and looks 4 and 4 of the scissors and paper. Is that up to 15? Yeah, that's 15. If we just do this a couple times, just sort of make some observations about what's going on. First thing I can see is that it's always in decreasing order left to right, and that's because Pandas goes ahead and sorts the data for us when it does the value counts. It's going to give us the largest value first, down to the smallest. So here we can see we've got 8 scissors on the left. If I run this a couple more times, now there's more rocks, 9 rocks this time. So that's the leftmost one. For comparison, that seems a little not quite ideal. It's not exactly what I'd like. So let's sort these guys by item instead. I'm just going to copy this. I'm going to grab a new cell. So guys who are following along at home can come back to this later. So to do that, I'm going to call sort index on this. So right here, I was using VC to print it out. I'm going to say VC equals VC dot sort by index. There we go. And we'll keep the plot there. So this is now going to sort things for us. And it's going to do it alphabetically. So I've got P for paper, R for rocks, S for scissors. Yep, they're in alphabetical order. I can do this a bunch of times also. And they stay paper, rock, scissors, paper, rock, scissors. And we can see that the bars move up and down. They're no longer in sorted order. So this might make it a little easier for direct comparisons as I go through. I'm still trying to figure out, is this biased or not? And I'm looking like I'm getting things that are all over the place. And now I'm thinking about it, to be honest, I would really prefer that the order be rock, paper, scissors, like the traditional game. So just one more quick thing. This is more of a review item than anything else. I'm going to go grab another cell. Here we go. We'll put that same code in there. But now, instead of sorting with the sort index, please remember that I can access any series using the square brackets. And I can put a number of things inside these square brackets. And one of the things I can put in is I can just write rock, for example. And do that. When I run this cell, I'm not printing it. Hold on. There we go. When I print that, it's going to give me the value. I can also put in a list of things that I want to get out. So in that case, I need a new list. So I'm going to add some more square brackets. So the outside, the green ones there right now, are telling me to access data from the list. The black ones are telling me that I want to get which columns I want. And I can put them in the exact same order that I've got right here. So I'm just going to copy and paste my rock, paper, scissors inside that list. And now when I run this, it should give me basically grab the rock, paper, scissors, keep them in this order, and tell me how many times each of them appeared. So if I run this a number of times, it should stay rock, paper, scissors, rock, paper, scissors. It should always be in that same order, no matter how many of these are here. So next up, I'm going to go ahead and put my bar plot back. And now we can see that rock, paper, scissors. I know you guys can't see it when I'm touching the screen and pointing at it, but trust me, I'm pointing at the rock. It always is going to stay there on the left, no matter how many there are. Paper is going to be in the middle. I love it. Okay, it still looks like there might be a little bit of maybe paper comes in more often than the rest of these. I can't tell. It seems to be a little bit deceptive. So, check this out. I actually planned to do that and forgot to move these down. Let me do that right now. So put this cell in the sorted by rock, paper, scissors. We'll put this cell sorted by item. So when you guys come back and look at the lecture notes, up here I've got my lecture version. There's a worksheet version for you guys. So both of them will be available. You can see the exact work I did. They'll be in the right spot. Okay, so it looks like the next question I want to ask, it's the same question, is this really fair and how can we address this? And maybe one way to do this would be to look at a much larger sample size so that any of this like little random distribution that we're seeing, you know, the perturbations, it's not exactly the same every single time. We'll sort of get averaged out. So let me just go back and do maybe not 15 trials, but how about, computers are really powerful, how about 1 million? So that's 1, 2, 3, 4, 5, 6 zeros. Let me make a graph of this. You know, in fact, 1 million isn't exactly divisible by 3. Let's go with 3 million. We'll do that. And indeed, computers are powerful. I did that blazingly fast. And we can see we're getting numbers that are all really close to 1 million. This is slightly over. Those are slightly under. The bars are almost the same height. Let me just run this a couple times. What did I do wrong? Kernel, it died. Oh no. All right. Restart, run them all. All right, so maybe 3 million is pushing the limit for what Jupyter Notebook could handle. So I'm going to move on. I do have a pretty nice computer here. Okay, so next up, I can control the probability of selection. So I'm actually going to go back. I'm going to grab this again. Get a new cell right here. Put that in here. Maybe let's not do 3 million, but we'll drop that down to maybe 300,000. That should be easily doable for my computer. And then my choice function right here, that's up to that parenthesis right there, can also take another parameter, p. And this is going to be a list of probabilities. So suppose I want rock to appear 70% of the time, paper to be 20% of the time, and scissors 10. These need to add up to 1. Oh wait, 70, 20, and 10 add up to 100. I want 0.7, 0.2, and 0.1. Now they add up to 1. Let's throw some zeros in too. Yeah, that's looking really good. So then when I do this analysis, what I'll find out is that I actually have control over the probability. So I can say that rock is going to appear far more often than paper and scissors. I can change these around. I could make the rock probability 10 and the scissors probability 70. They just need to add up to 1. If I mess that up, it gives me an error message saying probabilities do not sum to 1. Let me put that back for the folks at home following along. And these numbers match up exactly. So this rock is at position 0. The 10% is at position 0. Paper 20. And finally in this section, let's see, there's a shortcut if we want to do a random selection from a list of integers. So let me grab another cell. And let me just do, I'm just going to copy this much. And then I'm going to get rid of this much. And I'll just do a much shorter sequence. And then if I wanted a list of integers, I could do, 1, 2, 3. Oh, we're computer scientists. We'll start with 0, 0, 1, 2, 3. And then I could fix my mistake. I missed in parentheses. There I get a sequence randomly selected from the 0, 1, 2, 3. 2, 3, 2, 2, 1. If I run this a couple times, eventually I'll see a 0 in there. There we go. But there's a shortcut for this. Because choosing a list of integers is so common, that I can just stick in a number right here, and that's going to choose a number between 0 and 5. So things that are less than 6. So I should never see a 6 no matter how many times I do this, but I will get the 0. Okay, so just a quick note on that shortcut. We'll use that in a little bit. Next up, I'm going to pop back over to PowerPoint and talk about bugs. One of my favorite topics is how to not write code with bugs. And as you guys know, I write code with bugs all the time. I frequently make mistakes, so we want to talk a little bit about how to avoid doing that. Those life lessons that come with many, many failures. All right, be right back. So I want to start this section about bugs with a deceptive example of a bug that sneaks into people's code all the time. So here, I've got this particular line of code is just creating a series with, it's going to randomly select numbers between 0 and 9. I'm just going to grab 5 of them. Works perfectly fine. There's nothing wrong with that line. And then I'm just going to create a plot of these. So the sequence that I generated is 6, 7, 7, 3, 1. I'm plotting that 6, 7, 7, 3, 1 with a line plot. Next thing I'm going to do is compute the percent difference. So just empty list, quick loop through all of them. I'm going to start with 1 instead of looking at element 0. So this first thing, s of I, right there in my list will be the 7. I'm going to divide by s of I minus 1, the 6. So 7 divided by 6 is about 0.2, I guess. 1.2. We'll take away, we'll subtract 1 so we can see the actual percent change. Multiply by 100 to get a percent. That'll be my difference. We'll just stick that in the list and we'll get all of the, so there's 5.0, we'll get 4 in the list. And I'm just going to graph those. So series percents. This will create a series using this list, and then I'm going to make a line plot. So 7 divided by 6, take away 1 times 100. It's about a 20% change, a little bit less. Then the next two numbers were 7 and 7. That's a 0% change. And then I went from 7 to 3, so that's a decrease. So we'll see a negative percent change. And let's see. If it were 3.5, that'd be a 50% change. It's a little bit less than that, or a little bit bigger. So I'm seeing like about negative 60% change. And then 3 to 1 is a 66% change. All right, now this code runs, and it did produce this plot right here. But there's a subtle, little tiny niggling bug that may or may not occur. I want you guys to pause the video, stare at this, and see if you can spot something that might cause this to have a problem. Do that now. All right, so the problem we're going to run into is if I run this series, this first line creating the series a number of times, eventually I'm going to generate a sequence that has a 0 in it. And then if there's a 0, this will run through the list first time. It's going to take 1 divided by 9, get a value. And then it's going to try and take 0 divided by 1, no problem there. Then it's going to take 8 divided by 0. And not even Python is powerful enough to divide by 0. So this is going to give us an error. That's the bug. Okay, so there's two different kinds of bugs in the world. They're not all equal. We have scary bugs, and these would be in the, lots of different kinds of scary bugs, but this one is in the non-deterministic category. That means it sometimes happens and sometimes doesn't. I've got this code. We'll run it a couple times. We'll actually watch the error happen in live version in just a moment. So I found a picture of a scary bug, or Tyler actually found this. Badass bugs that you should have nightmares about. I just love that. I don't know if you guys can read it. If you're on mobile, that's the link. Freaky looking insect there. Okay, so non-deterministic bugs are scary. They're really hard to spot. And in fact, if you're writing code that generates airplane wings and you ship it out to your customer, and there's some randomness in there that you're using in your algorithm, sometimes they may come up with a random error that's going to divide by 0, and their code is going to crash for them. And then they'll send you a bug report, and as the programmer, it's your job to figure out what went wrong. But if it works perfectly fine on your end every single time you try it, it's really hard to spot those things. So nice bugs would be things that are reproducible, so that when the customer sends in their bug report, you can figure out what's going on, actually watch the program crash. So there's other kinds of scary bugs too. Some of them are system related. In fact, in P9, where we were printing out the list of files from directories, in previous years, we didn't have you sort them in reverse order. And it depends on what system the order they come out in. So students who are running the code on Linux, actually think about it this way. Some of the students were running code on Windows, and that produces the file list in a certain order. And then we were grading using Linux-based systems, and that's going to produce the answer in a different order, the list of file names, in a different order, and that was causing problems for students. So we fixed that this year by just requiring everybody to enter the files in reverse order so that everything was sorted, and we didn't run into that this year, hopefully. And randomness generally does lead to scary bugs when we start to see those kinds of things. Some things we can do to avoid seeing bugs: if we have a really large data set, maybe we can go and chop down and just use like 1% of the bug. That makes it easier to trace the code if we're not trying to scroll through a list of thousands of data points to try and figure out which one caused the problem. If I have a really small data set that reproduces the bug, much easier to trace the code and spot where it's coming from. And we have a way to turn semantic errors into runtime errors so that they don't sneak through. So if we already know something about the problem, we can use an assertion. Oh, I was supposed to ask you guys to remember what it was called. It's an assert. To put in what we know. We know we can't divide by 0. So anytime I'm divided by a variable, I should stick in an assert and just make sure that it's not a 0. That way it's going to crash and give me a meaningful error message when I see this happening. And one of the ways that we can reduce this non-deterministic bug is called seeding. And that's going to allow us to turn the randomness into something that's deterministic. So let me just talk about that for a little bit. The random number generators that we see in programming languages are technically pseudo-random generators. They are trying to generate a sequence of numbers that look random. And the way this does it is you can imagine a train going along tracks where each of the railroad ties has a number on it. And we're just going to be reading those numbers off. The idea is that no matter where I start on the track, no matter how far I go, no matter how many numbers I look at, it should look like those numbers came from rolling dice. They were just generated by chance. If I look at enough of them, I should see a distribution that matches the expectation value for really large sets. And every time I run my code, it's basically choosing from a different set of tracks. So one time it might choose this first track. I'm going to get 684, then 559. Actually using this code right here, making choices between 0 and 999, choosing 3 numbers. I'm going to get those. The next time I run it, it might choose a different set of tracks and run down. And then I'll see 37, 235, 908. So there's a way for us to remove that randomness from it and get the same sequence every single time. That's known as seeding. Random number generators basically take 2 inputs. They take the seed value, and they take either the previous number, or they'll take the number of integers it's already generated, something along those lines. What we can do is we can put in our own seed value, and then it's always going to give us this same set of numbers, the same railroad tracks as we go along. In fact, I'm absolutely certain that almost everyone in the class has seen seeding before. Give me 1 second to pull up an example. So my fans of Minecraft out there, if you were to go into Minecraft and create a new world, so if I pop open single player mode, there's other games that I play. I do love Minecraft, particularly the Techtopia mod. I can go to create new world, and this is my seed example. Under more world options, I can put in my very own seed for the world. So we'll put in 0, 5, 6, 7. If you guys want to play on this world and I want to play on the world, we're both playing on the same world, it can seed the random number generator. So we'll just create new world. You're going to get a Minecraft world with the exact same geography that I'm playing with, because it's going to use the same sequence of random numbers as it's creating the world. All right, we'll just give that a second to pull up. So if you look around, it looks like we're starting in a plains biome. Got the book because this has the Techtopia mod installed. If you guys get a chance, I really love that one. If I don't get the job in the fall, you can look forward to my new career as a YouTuber playing video games online. Oh, I almost forgot. So first up, I copied that same code from the lecture slide with the change over time. I just wanted to demo this and show that occasionally it's going to crash. So this is a great example. It's going to draw 4 numbers, and so I did 5 in my example. So it's going to draw, in this case, 4 numbers. And I see that I get 2 zeros. So on the second time through, it's going to try and divide by 0. And I'm going to get a runtime warning, divide by 0 encountered. But sometimes it's going to work. Let me just run this a couple times. There we go. This time it worked great. I got 9, 1, 3. So change from 9 to 1 is quite significant, almost 100%. Then 1 to 3 is a tripling. So we're looking at, well, 3 minus 1 is 2 times 100, so about 200% larger. Anyway, sometimes it works and sometimes it's going to crash. Very deceptive, non-deterministic bugs are bad. Okay, next up, how does seeding really work in Python? In this case, it's coming from the NumPy module, random, part of that package. The function is seed, and I can just give it any number I want. So how about 220? When I run this code, I've now seeded the random number generator. It's going to take track 220. So if I run choice, numbers between 0 and 999 inclusive, we'll just grab 3 of them for the purpose of this example. And there we go. We get 3 numbers. If I were, let me grab another cell. B for a cell below. If I run this again, then I'm going to get the next 3 numbers. So 883, 732, 15. And the next 3 are 180, 120, 514. Now, I can reset that and start over at the beginning of the tracks by, again, running this random seed function. We'll start it over at 220. We'll grab another cell. When I run this again, the choice function, I should now again see that I've started over at the beginning of the track. I get 883, 732, 15. Let me go ahead and just paste that in. We'll grab the first 6 numbers this time. I get 883, 532, 15. And then I see the next 3 numbers are, in fact, 180, 120, and 514. So seeding the random number generator is very powerful. Great way to avoid bugs. And frequently what we'll see is that people use... Sorry, that was my phone. What we do is see people will seed the random number generator with the time and then print out that in some sort of log message so that if the program crashes, they can send in the log message and the programmer can go back in their bug report and try and reproduce it using the exact same seed number that whoever was playing the game or designing the airplane wing used. So if I want to seed with time, I'm just going to grab the number of seconds since 1970. We'll need to import the time module, import time, and then the command, it comes from the time module. The command to get the time is just time. And this is going to produce the number of seconds since January 1st, 1970 at midnight. That's when computer science officially began, the beginning of the world for us. So what I'm going to do is, because the seed needs to be an integer, I just want this much of it. So I'm going to take, I'm going to store this in a variable, we'll call it now. And we'll cast this to an int, time.time, its function, and we'll print out now. So there it is, it's now an integer. And now what I can do is I can seed the random number generator. I believe I have this function right here. Let me just copy it. And we will pass that now. So random number generator now seeded with that seed. When I run choice, I'm going to get some numbers. What I really want to do is write this out to my log. Seeding with that number. I store this. This is going to be in my bug report. Now I can go back and try and figure out what went horribly wrong with my code. It's possible, if I'm choosing 3 numbers out of 1,000, that it's going to be quite rare that I actually get 0 and end up dividing by 0. So it's important to know exactly what seed was used so that I can see what kind of error message is produced. So this is going to lead us into a discussion of significance. And this is basically, if I've got a sequence of noisy data, if there's some randomness in my data, does a particular set of data support drawing a particular conclusion? And for my example here, I'm going to go back to flipping coin. Oh yeah, just for fun. A little comment from Dilbert. If you guys are on a mobile device and can't read this, I'm going to read it out. And if you can read it, then I'm sorry for wasting your time. See, we have Dilbert talking to a little monster here, little demon. It says, over here we have our random number generator. And then in the center panel, it's just another creature saying 9, 9, 9, 9, 9, 9. And Dilbert's asking, are you sure that's random? And the guy giving the tour says, that's the problem with randomness. You can never really be sure. And that's true. So what we want to be able to do is take data that's got some noise in it and decide if we can actually draw a meaningful conclusion from that. So suppose I have a friend come over. Actually, I can't do that. Everybody is forced to stay at home. So I've got my friend on Zoom, and they're going to be flipping coins. And we're going to be wagering money on this. So he's claiming this is a fair coin. And he flips it 100 times, and it comes out 51 times its heads and 49 times its tails. Now, can I say that this coin is biased in some way? Is my friend cheating using this particular coin? Basically, we're trying to decide if this data supports the conclusion that the coin is biased. And a statistician would say this is that conclusion statistically significant? Probably not. Probably not cheating. Probably a legit coin there. Now, if we do it again, he pulls out a second coin and flips it 100 times. If I see 5 heads and 95 tails, am I going to call shenanigans on this one? I believe, yeah, that sounds like there's a good chance that this coin is biased. And it's possible for this result to happen, but the odds that it happens are quite slim. Now, I want to take a little bit different perspective. What if it's 55 versus 45? Do I call shenanigans in that place? So what we're going to be looking at is that in the next example, I'm going to jump back to Jupiter and see how often does this really happen that I'm off by 5 or off by 10. What if my friend flips it 100 million times and I see that 55 million times I get heads and 45 million is tails? Do I want to call shenanigans in that case? For the 55 and 45, I probably don't. For the 55 million and 45 million, absolutely. Yeah, no and yes. Okay, so one of the things I can look at for to make that decision, if I see a large difference or skew in a very small sample, that's pretty good evidence that there's some bias there. And if I see even a small difference, something that's perfectly reasonable for a small data set, when I have a really large sample, that's also really good evidence that things are biased. In fact, this is how casinos make all of their money. They're looking at millions and millions of transactions with even just a small bias so that it's hard to tell. Okay, so what we're going to do, I'm going to jump back over to Jupiter and try and see if we can decide whether 60 heads and 40 tails of 100 coin flips is representative. How often does this happen? If I see this, is this a good enough example to count, to call shenanigans on my friend? So we'll be flipping it 100 times. We'll count how many times we come up with heads, and we'll repeat this 10,000 times and just see how often this happens. All right. So is it weird that we have 60 heads and 40 tails? So basically the question I'm going to ask is, how often are we more than 10% or more than 10 away from the expectation value? So in this case, I want to select 100 times. So choice, I'm going to want to either get heads or tails. So I'm just going to abbreviate those heads. Whoops. Tails. And then I want to choose size is equal to... Now what I want to do is I want to do this lots and lots and lots of times. So I'm going to let the rows equal how many times I want to have, how many trials, I guess. So we'll have trials, and then the columns is going to be how many times I flip the coin. So call that flips. And just to make sure I'm not hard coding this, so I can tweak the number of trials, what I'm going to have is trials is equal to 10,000 and flips is equal to 100. Now this is actually really big. I want to print the data table and take a look at it. So let's start out with 3 flips per row and maybe 10 rows. We'll start with that. Okay, let's see what that looks like. So I'm getting, here it is. This is a NumPy array. So an array of arrays. And so I got tails, heads, tails, tails, heads, tails, heads, heads, tails. Okay, so it's looking like it's working. So let's go ahead and put that in a data frame. So I'll store this as data frame equals, and then I can just write data frame and stick this choice function inside of that. It'll generate the list of lists, and that gets turned into a data frame. And then I'd like to print that out. Sorry, I forgot that line. So there we go. Beautiful looking data table. Now, it's actually a little bit easier to count how many times I see tails and how many times I see heads if I abbreviate heads as 1 and tails as 0, because then I can just add them all up. So let me grab another cell, make a copy of that, and I'm going to switch this from heads is equal to 1, tails is equal to 0, and then I can add them up. So make sure this is working. There we go. It's a list of lists, so I'm looking at numerical integer indices. Then I can go ahead and let me grab a new cell. We'll copy this again. Just take the sum of these. So to do that, I'm going to take my data frame, call sum on it, and this is going to add up all of the 5, 6, 3. That's more than 3. Oh, I know what this is doing. This is adding up the number of heads we see in the column. So in this case, I didn't actually print out my data frame. Let me do that. Then we can see what's. I didn't print it either. Print data frame. I'm going to make sure this is really what it's doing. Okay, so first column here has 1, 2, 3 heads. So column 0, 3 heads. Okay, so what I really want to do, the default is to add up the columns. I want to add up the rows. So to switch that, the sum function takes a keyword parameter equal to axis. And the first column is going to be rows, the second one's going to be columns. So I want to switch this from axis 0 to axis 1 and add these guys up. So now I've got 0, 0, 1 has an occurrence of 1 head, 0, 1, 1 has 2. Okay, so that looks like what I want. So next up, I'm going to go back, and what I'd like to do is now use the big numbers. So instead of 10 trials, I'd like 10,000 trials. Instead of 3 flips, we want 100 flips. And let's just take a look at this real quick. So I'm printing out my entire data frame. It's abbreviating it. So I can see all of the flips up to 99, 0 to 99. And then I can see that in row 0, I had 48 heads. Row 1, I had 56 heads. Row 2 equals 47 heads. So I'm looking for ones that are less than 40 or greater than 60. Looks like I didn't get any in this first run. Let me run this cell again and see just how often. There it is. There's a 61. So it does occur. Now, I'm going to go ahead and grab another cell. What I'd like to do is just count those. And I've got 10,000 here. So what I'm looking for is, what did I name that? I didn't give it a name yet. Okay, so let me take this sum and we'll name it counts. There we go, counts is equal to that. Let me run this a little bit and make sure that I actually have, I'm no longer printing it out. Sorry for all the mistakes. I know that slows things down. So there we go. Do we have any less than 40, greater than 60? There we go. There's a 39 in there. So if I look at counts less than or equal to 40, for example, this is going to return a Boolean series, and I'm going to see I get true for this 39 right there. If I look at counts greater than or equal to 60, none of these were, the ones that are showing here, none of them are greater than 60. Now what I want to do is actually add those up. So if I take and use this Boolean series to select just these rows, that'll give me a new series, and then I can use the length of that series to get the count. So I'm going to be using counts. We'll be extracting with the axis brackets let's do counts less than or equal to 40 to start off with. This is going to create a Boolean series. I'm using it to select things. So in this case, I'm looking at only things that are less than 40, less than or equal to. And what I really want to do is get the length of that. So we'll give this a name. These are the extremes, and we'll get length of extremes. We'll run this, and it turns out that 266 out of the 10,000 that I ran had less than or equal to 40 heads in the list. All right, now I care about greater than or equal to 60 also. So what I want to have is or counts greater than or equal to 60. Now, if you remember, when we were looking at pandas, or was one of the operators they couldn't override. So they overrode the vertical bar there, the pipe instead. And that vertical bar is a real Python operator. It has really high precedence. So I'm going to need to stick these in parentheses also so that these happen first. So I want to create those two Boolean series and then use the OR operator to merge them together and finally use that. So it looks like in this example, I'm getting 539 trials that have less than 40 or greater than 60. Now, to compute the percentage of that, I need to do one more little thing. Take the length of the extremes, and I'm going to divide by how many trials I did. Oops, so I believe I called that trials. That'll give me a percent as soon as I multiply it by 100. So it's looking at, in this example, getting less than or equal to 40 or greater than or equal to 60 happens 5.39% of the time. If I rerun the entire notebook, I should see that I get something close to that again. There we go, 5.32, more or less. So it is likely that we'll see this, 1 in 20 more or less. There's 144 people in our class. That turns out that if everybody did this experiment where they flipped 100 coins, about 7 people in the class would see that they got either less than 40 or greater than 60. So next up, for you guys at home, what I'd like you to do is go back to that opening example, the one where I had the 16 coins, I flipped them, and I asked you guys to decide which one you thought was real and which one was fake. Go ahead and take what we just did here and see if you can apply this to figuring out how often can we see 11 or more heads. So pause the video, work through that, and when we come back, I'll play the video. I'm going to go through the example and show you how to do it. So one sec, be right back. Okay, so to take a look at this problem, let me grab a cell to do the work in. First thing I'm going to do, flips is actually equal to 16 now. Trials, we'll go with 10,000 again, just to make sure we have a large enough sample that we can see how often this happens. We'll create a new data frame where we're giving this choice. Now the choice is going to take 1 for heads, 0 for tails. It takes another parameter size, and that's going to equal my number of, we'll give it a tuple, so the number of trials for the number of rows, and the number of flips that we use, in that case 16. Then, let me think, we'll do the sum of the rows, so I want counts is equal to my data frame, sum, and I want x is equal to 1. And then the result that I get is going to be equal to, in this case, here's where I want to go ahead and access counts. Whoops, square brackets, because I want to create a Boolean series to extract only the trials that have 11 or more heads. So to do that, I want counts greater than or equal to 11 heads. Yeah, that looks good to me. And then let's see, length of result will be how many of those trials actually have more than 11, and divide by trials, so 10,000, and turned into a percent. All right, let's see what this looks like. All right, so interesting. It looks like when I do 10,000 trials, flipping a coin 16 times, approximately 10% of the time we'll be getting 11 or more heads. So it's not unreasonable that the data shown in my very first image there is legit. Okay, next up, what I'd like you guys to do is try and answer the question, how often do we see 7 heads in a row when I flip 16 coins? All right, I'm going to pause the video. I want you guys to do the same. See if you can work through that, and then I will show you my solution. There's actually a ton of ways to do this particular problem, so my solution is only one way. You guys, if everybody in the class does it, we'll have basically 445 different solutions. Okay, so my approach to this problem, let me grab a new cell and walk through this. What I want to find is how many times I see 7 or more heads in a row. We'll start off counting with 0. And I'm going to do 10,000 trials. But to start us off, what I really want to do is choice. I'm going to call the choice function. I'm going to give it either heads or tails. And we'll do 16 flips. And I lost the comma. There we go. So here's my sequence of flips. Do we get 7 or more heads in a row? Nope, not in this one. What about now? 1, 2, 3, 4, 5, 6. Almost. So what I want to do is a way to detect if I see 7 or more heads in a row in the list. So what I'm going to do is I'm just going to join these together into one word. So the keyword for that, it's a string function called join. I'm going to give it the empty string. Now when I join those together, I'm now going to get a sequence of letters that look like that. So we'll stick that in a string. So S is the variable name. And then we'll do and see if we can find 4, 5, 6, 7 heads in a row. When I do this find function is either going to return -1 if that's not present. So let me print S. We can just make sure this is working. So -1, it's not there. -1, -1. Oops, Control Enter. I'm just going to click this till we get a non-1 answer. Oh, there we go. An 8. So this is going to tell us the very first character or the very first index where we see 7 H's in a row. So 0, 1, 2, 3, 4, 5, 6, 7, 8. There it is. Now I've got 7 heads in a row. So what I'm going to do is do this 10,000 times. So I'm going to put this in a loop for I in range trials. So, and then this will be in the list. I don't need to print it out every single time. Find. So what I want to do is if this is not equal to -1, then forgot that. What I want to do, 7 or more equals plus equals 1. There we go. So this will increment 7 or more, my variable, every single time I find 7 heads in a row. All right, and then the very last thing, 7 or more divided by how many trials we do, times 100 to turn that into a %. All right, we'll run this real quick. So it looks like 4.12. Let me run this a couple times and just have a look. 4.19, 4.32. So about 4.2% of the time, we'll actually see that we get 7 or more heads in a row, flipping 16 coins. So of the 445 people in class, that means approximately 17 or 18. Oh, in fact, I can multiply this by 445 students in class. Oh, that's not right. I want to not do this much. We'll see that 17 or 18 students actually get 7 or more heads in a row if everybody flips it 16 times. Okay, so this is going to wrap up the lecture for today. I'm just going to finish with some closing credits and want everyone to go and have a really great summer. So just a quick message from all of us on the team. That we have 2 of us are instructors. We've got 9 TAs and 9 mentors. There's 20 of us who've been working very hard all semester. We just wanted to finish with some little photo credits. Not everyone sent me a picture, and I didn't hunt down the rest of the team on the internet. But anyway, just I had a great semester. Mostly I did this for fun when I signed up. I did apply for the full-time job. I love it. This is what I want to do with my life. So go fill out the evaluation. My partner Mina, she's been teaching the other half of the class. She's got 2 sections and is actually continuing on. She's the full-time faculty member on our team, and we'll be teaching CS 220 in the fall. If you're interested in being a mentor, send her an email. All right, and then from some of the other TAs, from Yuchen, if you guys are reading this on mobile, it might be tiny. So her message for all of you is thank you so much for all of your hard work. From Sean, we have thank you and stay safe. And I got to echo that, definitely. Stay home, stay safe. From Bhavya, I like this one. Data doesn't lie. Data scientists do. He was one of our head TAs. From Zenmi, good luck this semester and in your studies at UW-Madison. And from Saurav, we've got good luck with data crunching. Go grab them all. And finally, from Tyler, Tyler is the one who taught this class in the previous years. I used all of his resources getting ready for my lectures and to adapt a lot of the material for online use. But he's continuing on in our data programming sequence and wants everyone to know that you should take his class, CS 320, next fall. If you guys think I did a good job, it's all due to him. Well, he saved the foundation for everything I did, and without him, class would not have been as good. All right. Anyway, thank you all for paying attention all the way through the end, and have a great summer.